All right, so let's get started. So, what does college prepare you for? So, of course, we don't want to say college is is unnecessary, but college does prepare you to be disciplined. It does help you kind of get things on a schedule. It should help. It should motivate you, get you to work with others, and kind of it basically helps you work within specific parameters. That's a good thing. It will kind of prepare you for the workforce. All right. The one thing I will say as a project manager at an engineering firm, one of the things it doesn't really prepare you for, I see this the time over again, is kind of real life projects, which I kind of hate to say that, but that's just kind of how it is. They give you a lot of theory, they give you some basic examples, but they don't really get you into the real life workflow. When you get to a company and the boss says, okay, I need you to do this for me, it's not usually the person who's asked at it does not know what they're doing, and any further training and so on. Also, they don't educate you with using design standards, which is a crucial part of understanding how to actually get a project done. And of course, the biggest thing in this day and age is the software. That's really crucial as far as really having a good basis for actually getting a good job and actually working with the engineering firm. All right, so let's go over today what the actual process is. And again, every agency is going to vary. I'm in the States, United States, and every municipality will vary, but there is a generic type workflow that you will typically follow. There's minutia in every part of the process, but for the most part, that's what I'm going to discuss in this presentation. All right, so the first thing I always say that you really want to kind of, and again, this is something you can do on your own, wherever you are. You can really educate yourself with what are the design standards in your region of the world. Where are they? Where do you find them? Deciphering them. Just to kind of give you some examples here. So I'm in Florida in the States here, and this is a set of Florida DOT standards. And so the reason that you want to be really familiar with these is that when you're designing your projects, the biggest thing that you'll do is, the engineer will say, okay, well, did you look at this? Did you look at the design standards? Have you checked this? So for instance, if I was doing, guardrail design, and that's you'll have these different kind of numbers that will, relate to the specific thing that you're designing. So here's, let's see, 53601. And so if I bring that up here, you'll see there's a whole bunch of notes and dimensions and ways of actually doing this. So for instance, if you were doing some guardrail design and you're actually going to draw it up, let's say in CAD, then you're going to have to know exactly how to draw that. And that's one of the things that these standards will do. So for instance, if I zoom in here and I need to know, I have a project that is unpaved, it doesn't have a paved shoulder. So you're going to have some sort of lateral offset, and those will be defined here. And then basically here's the actual dimensions to actually design and show this within your plans. And so this is the type of stuff that you want to really get familiar with, again, depending on where you work. And of course, you're going to actually have multiple. You're going to have cities, you're going to have counties or ministries, etc. So they're each going to have their own flavor of standards, and you kind of have to work within all of them. So you really want to make sure you kind of have a good grasp of what design standards are. All right, so taking down from the beginning of a project. So typically a project will either be handed down, or a county or agency will get funding through an agency themselves. And then you are, before you actually even kind of start to build a project, you actually do a project scope. The reason you're doing this is that initially what they're going to do is they need to budget the right amount of money to get this project constructed. Now, of course, you're not going to invest in actually designing it, because then what if the project doesn't get approved and that kind of stuff. So each project will have its own specific design criteria. As I said in the second, visit the project, again, hopefully you'll have someone with experience that you'll obviously do it with. And they'll, go out there in the field, and you'll actually know, okay, well, we've got some bad paved areas here, we need to fix this. Or if it's a reconstruction project, basically a project that's taking a dirt road, let's say, and turning into a paved road, there's all kinds of other things that need to be kind of figured out. Like, are there going to be ponds needed? Because typically agencies, if they're going to pay for a road to be done, they do not want to just repave that existing road. They want you to actually look at the current geometry, and do you need to fix that geometry? So if you do fix that geometry where you're actually going off of the existing road, you will have to create a pond. That is just the way it's done, because that road needs to be treated in areas that are newly, within the actual areas that aren't road. Will a survey be required? Are there wetland issues? Are there habitat issues? Here in Florida, gopher turtles are a species that you have to worry about. So these are things you actually have to kind of get an area. Do you have that issue within your project? Are you connecting to an existing agency's road? If you are, you have to get a driveway permit. So these are things that you have to kind of think about. One of the things you may do, I've done this on a couple of projects, and I'll kind of show this to you, is you will have to do some preliminary modeling. And what's nice about some of the software out there is they actually provide a nice, quick, and easy way, and you can just get basically kind of state agency data for surfacing, for surfaces, and it's not as accurate as it would be if it was actually surveyed, but it's good enough to kind of get a general idea of what the project should be done. So this project here is a 5-mile road, and what it does is we're basically reconstruction. So it's going to pave the existing dirt road. There's a lot of drainage issues in this project, so there's going to be some spots where we have ponds and other things like that. But this software here is called Autodesk InfraWorks, and what it does is it allows you to easily, basically gather data. So you can see here, this is a parcel of a property owner. I've actually brought that in. Notice how it's actually in kind of a 3D type way because the surface data was actually brought in through LiDAR, which is freely available by the Water Management District in this area. So if you don't have the water management or you don't have free data, you can actually usually get stuff from an agency, and that you can usually download their USGS or basically their state kind of contour maps. Okay, they won't be as accurate, but they'll be close enough for what you need to do. And the reason why I was doing this was to make sure that I could get this road to fit. You'll see here, as I'm kind of going along here, this is the existing road, but because this road needs to be put up to a 55 miles an hour, this actually, you can't fit this curve. This curve is not going to fit within that realm of 55 miles an hour, so it has to be realigned. So by doing this, it was a quick and easy way for me to say, okay, yep, I've got a pond there. If we look at another spot here, I'm going to actually have another pond. Notice how I'm going off of the existing here, so there's going to be a pond over here. And also, this was able to stay on. And this right here, because this was a 90-degree curve, we had to have a pond over here as well. And further on, you get the idea. And of course, it just allows you to kind of see the actual project really nicely. Again, I'm not spending too much time doing it, but you're going to need to know these because the other issue is right-of-way. So are you going to need to acquire right-of-way for that project? If so, the county or the state agency needs to know that because they're going to actually obviously have to pay the property owner to acquire that right-of-way. So those are the types of things that you'll do. Are there bridges, water crossings? I showed that visualization presentation, or mentioned that here because obviously, and showed it to you because it's obviously something that may need to do to actually kind of sell the project or show some of the issues that may occur. One of the next steps that you would do is you would develop an estimate and a task work order. Okay, and the reason you're doing this is that, again, the agency needs to know not the exact, but a good amount of money, what it's going to cost to actually construct that project. So what you do is you'll go through the project. Again, this is why you need to know, are there ponds? Well, that's going to require some additional excavation, right? So, you're going to have some more cut volume. Are you going to actually have fencing? Are you going to have guardrail, etc.? So that's for the actual roadway project. Now, at the engineering firm you work for, you may or may not be a sub, or you may be the main consultant where you will have sub-consultants like geotechnical or environmental mitigation, etc. So if you have to get borings, because every pond, usually the water management agency will require that you do one boring per acre. Basically, they want to see what the existing soil is going to be, so that you're making sure you put the proper pond in there. So you're going to have to that's going to require boring. So again, this is something you have to include in the estimate. And then of course, same thing with wetlands. If you have wetlands in the area, or if you think you're going to have wetlands in the area and your road is going to impact them, then you actually have to take that into account as well. So you're going to get mapping from an environmental engineer, and they will map it for you, and then survey will locate it so you can have it on your plans, and basically then you'll know what mitigation you may or may not need to do. And basically every state agency will usually have a state average of pricing, and most engineering firms as well will, if they've actually taken a project from beginning to end and then actually out to the bid process, they'll actually have the pricing. They'll start doing their own state averages or averages in their area. That way you can actually have the the actual estimate that you can get, as much as or as close as possible to accurate. Now, one of the things too, of course, they'll put fluff factors in it because obviously you can't, say everything. So they'll probably put a 10% factor in there. Of course, once that's then sent and then approved, then you'll get what's called notice to proceed. This will usually come from a state agency or a county commission or a municipality, depends on who's paying for the project pretty much. All right, so once you are ready to go, what goes first? And so it actually depends on the project. So if you're doing a simple resurfacing project where all they're doing is milling the road and resurfacing it, you're not going to need survey, typically. Some agencies will want to see the existing ground, but most likely you don't need to. It's a very simple project where you're basically just getting a square footage or square meterage of actual pavement or milling or whatever it's going to be for the project. Okay. Now, if you're doing reconstruction where you're actually changing the alignment, you're changing the profile, you're going to upgrade that road, you're going to need survey. Now, while survey is being done, you can start working on the 2D plans. And what I mean by 2D plans, I've actually got a set of plans here that's completed. So this right here is a quote unquote 2D plan. In other words, it's just text and an overall map of the project. This here, 2D plan. This too, 2D plan. And these are all 2D plans as well. It's just details of the project. Now, as we get to the plan and profile sheets, this is what I would call like 3D plans. Again, this is a 2D drawing. However, it's getting the data from actual 3D information, like the profile right here and the horizontal alignment right here. Okay, so these plan sets you would kind of wait because obviously you don't have the plan and profile defined yet. But the 2D plans, you can begin doing that, and that's probably what you would begin working on is the 2D plans because they're easy enough to get to, surveys getting done, etc. Okay. Once that's done, then you'll start getting into the 3D modeling aspects of things. All right. With a roadway project, of course, the first thing that you'll do, and again, you would have already kind of done this anyway. You would, in the preliminary stages of the project, you would have defined a somewhat close horizontal and vertical, not vertical probably, but mostly a horizontal alignment. That way, you know what your corridor is going to actually look like. Okay. So that will be done. But once you get the survey, then you're going to go in and actually you're going to fine tune that horizontal and you're going to really go in and design the vertical alignment. You're also going to start to think about things like super elevation. If you're not familiar with super elevation is basically when you have curves in a road. You may or may not notice this when you drive them. The road should pick up on the outside of the curve. And on the inside, you'll notice that it's kind of going down, right? It depends on the way the curve goes. This is a right-handed curve. It goes to the right. And so basically, the road will pick up so that, of course, due to inertia and gravity and all that type of stuff, the car doesn't just go, you don't feel like you're going off the side of the road, right? It helps you in the curve. And so you have to think about these things because as you're developing your horizontal alignment, that transition into the super elevation and out of the super elevation needs to be kind of calculated. And there are spreadsheets that you can, that you'll use to do this. But if you're going in and out of curves, you have to make sure that your runoff ends, your tangent runoff ends actually before you begin another curve. Because if it can't run out, then you're going to have to do what's called an S curve. And that's basically where you go to level crown, and then it goes back up the other way. Let's say you have a curve that goes to the right and a curve that goes to the left. So, but if you can't avoid that, that's better for roadway design. And so these are the types of things that you need to kind of think about. And just to kind of show this to you, actually in the CAD software here. So I'm in a file here. This is a completed project, and you'll see here that my horizontal alignment. This is following an existing road for the most part. In certain spots, it does not. So you can see here, I've got a pond, right? Right over here is a pond. Because I'm not on existing, we have to treat that water that's coming off the road here. But you'll notice I have these curves here. So this super is running out over here. I've got plenty of a tangent or straight line area where I can run out that curve, that super elevation. But then you'll notice here as we come up here, this is fine. But if you look over here, so this is a left-handed curve, but then I'm coming into a right-handed curve. So this project, or this location, I could not run out. So this is like an S curve. It has a small tangent section. It actually does, but the tangent section was not enough to run out the actual super elevation. So this basically goes up here on this side, and then it hits zero elevation or zero crust slope both ways, and then it goes up this way to this way here. Okay. So these, but then, again, so I had to tweak this alignment to at least get to that location in the horizontal to make it work. Okay, that's the horizontal. Then for the rest of this project, it pretty much just follows existing, so there's no ponds here. Now here's your vertical or profile. All right. So typically, again, this is why you need to know your project. You know what is expected. You know, when you design the vertical, you don't just slap it in there. You have to. The biggest thing you have to think about is drainage. Where is the water going? So in this case, you first want to know where your existing water is. So here's my existing. You can see I have a low. And so I have to make sure that my proposed goes exactly where that is. We're not going to re-put a low over here because that's just not the, obviously there are people who live on this road and flooding would occur and different, you know, they're used to what's going on. And that's why you design your road to follow the existing terrain for the most part. You notice we have a lot bit of fill here. And this project was the water table is very low in this area. So we wanted the ditches to be dry. So we have to raise the road for that to occur. As you can see here, we're kind of maintaining and following existing. Here's a low. And if you look here, here's a low. So notice how the road is doing that. And then you'll notice for the rest of the project here, this is actually going to a bridge. So yeah, there's a little tiny bit of a low here, but for the most part, all this water drains into this creek over here. Okay, so as you can see, of course, you know, things like this, you know, I'm going to actually follow existing where it needs to be followed because I'm not going to change this location. This creek is working the way it's working for a reason. Now, of course, as they're doing this, the type of stuff that you have to think about, a hydrology engineer is going to come in here and say, okay, we need to do a small little hydrology study to make sure that it's not flooding during an event of some sort. And you obviously then would either raise the profile, or if it's fine, you would keep it at the existing elevations. Now, again, we're based upon history of the road. If it's never flooded, that's usually would be okay, but they'll still do a study just to make sure. So again, that's your horizontal and that's your vertical. All right. And the other thing you have to think about is balancing your cut and fill here. Now, so the vertical alignment, if you're not familiar with it, is basically it's the elevation of the center line of the road, right? So this is like a cross section of the entire road and what it would look like. Okay, that's what the profile view is. And you can see here in most of the cases, I'm actually above because of this unique situation with this project. But for the most part, you'll typically be, about a foot or two above the road because you need to take into account the new road bed. And basically that's, for your ditches to work, that's how it's going to actually kind of tie everything in. But the other thing you have to think about is balancing your site, balancing your road. In other words, you don't want too much cut volume where they take out that dirt compared to your fill volume. I mean, again, every project is different. If you know you're going to have fill, then that's just how the project is going to be. But for the most part, you want to balance your road so that any cut that they take out of that road project, they can use as fill in the spots that need to be filled. So that's basically kind of the stuff that you have to think about as you're doing your horizontal and your vertical. All right. And like I said before, do you even need a vertical alignment? So if it's a simple resurfacing project, you're not going to have a vertical alignment. You'll just simply do a plan sheet where it's basically a plan sheet up here and a plan sheet down below. It just tells the contractor what happens at those different stations, whether you have guardrail or you're fixing a catch basin of some sort or something like that. All right, so after you have your horizontal vertical, and again, before you even do this part here, you would get that checked by the engineer. And you might even get it checked by the agency. All right, so it's usually because when you start to get into the modeling process or the typical section, where you do actual road, you want to have that kind of done. Now, the great thing about the software that we use nowadays, it's all dynamic modeling. And what that means is if you change any aspect of the horizontal and vertical, it just updates the model. So it's really, really nice. Whereas in the old days, about 20 years ago, 30 years ago, you did not have that functionality. If you changed the horizontal vertical, you had to redo your model or redo your cross sections kind of by hand. And so it was kind of a pain. Whereas now it's really not a huge deal if it has to be changed. Okay. So once that's all approved, then you obviously already know your typical section. You'll have 12-foot lanes, paved or unpaved shoulders, and then your end conditions. Are you going to have a ditch? Are you going to have a fill slope, etc. Now, once that's done, you may revisit the right-of-way because remember the right-of-way was thought about beforehand, but that was just preliminary. That was just basically a conceptual modeling. It wasn't even really modeling. It was just more of just, hey, can this kind of road fit with these basic variables? once you now actually have the road, you may actually have to revisit and actually redo your horizontal. So you might be going back to this stage here to take care of the stage where you may or may not have to be concerned with right away. All right. And just to kind of show you that here, so this